Assalamualaikum warahmatullahi wabarakatuh. We are from class CS249 3B2. We will present our group project about relationship between total advertising budget and sales. For introduction, one key aspect of the analysis of marketing is examining the relationship between the total advertising budget, variable X, and sales, variable Y. This consideration is necessary for helping firms ascertain the impact of their investment into various media platforms. In the data set provided, the total budget includes the sum of the money spent on television, radio, and newspaper advertising. Subsequently, sales depict the revenue that has been achieved. The analysis of that data is requisite for analyzing how changes in the total budget affect sales and patterns of the two variables and whether increased spending in advertising translate to higher sales. The result will aid in designing marketing strategies and using resources most profitably.
To find equation curve using LSQ method, firstly, we need to convert the data into the form of linear equation ax plus b equal to y. Second step, we need to form matrix M, V, and Y. Then, we need to transpose matrix M. Next, multiply matrix M transpose with matrix M A and multiply matrix M transpose with Y, B. Then, inverse the matrix M transpose M to find a matrix I. And lastly, to find the value of A and B, we need to multiply matrix I and B. By that, we get the best fit linear curve is y equal to 9.9783 plus 0.1121x. Next, to find the error vector and magnitude error vector by using formula E equal to y minus mv. First step is find matrix mv by multiply matrix M and matrix C, which is value A and B. Then, minus matrix Y and mv to find matrix E. Lastly, square root the sum of square E to find the magnitude error vector.
Now, for quadratic model, firstly, convert the data into the form of quadratic equation by using quadratic formula, which is y equal to a plus bx plus cx squared. Next, represent quadratic equation in the matrix form. Then, find equation of curve by using LSQ method. First, find transpose matrix M. Second, let matrix A equal to transpose M multiply M. Third, let matrix B equal to transpose M multiply Y. And fourth, find inverse matrix A. Then, we continue from previous slide. Next step is let C equal to inverse matrix A multiply B. And lastly, substitute the value from matrix C into quadratic equation. Now, find the error vector and its magnitude. First, find matrix MV, which is multiplying between M and C. Next, find error vector using its formula, which is E equal to Y minus MV. Then, find magnitude of error vector by using square root the sum of square E.
Okay, now, for the cubic model, we need to convert all the data to be in the cubic form, which is y equal to a plus bx plus cx squared plus dx cubed. Then, we can change the cubic model to be in the matrix form mv equals to y, which is m equals to x point, v equals to a, b, c, d, and y equals to y point. Next, we need to find the equation of the curve by using LSQ method. So, firstly, we need to transpose the matrix M and multiply the matrix M transpose with matrix M. Then, we recall it as A. After that, we multiply the matrix M transpose with matrix Y and recall it as B. Then, we inverse the matrix A. After that, we need to find the least square solution, which is C. We multiply the matrix A inverse with matrix B. As a result, the point A, B, C, and D is found. So, we get the best fit cubic curve as follow after substitute them into the cubic model. Then, we can continue to find the error vector and its magnitude by using its formula, which is projection y equals to mv. First, we multiply matrix M and matrix V to get the new matrix. Next, to find the error vector, we can subtract matrix MV from matrix Y, so the magnitude of error vector is approximately 2.4732.
For the graph linear equation, against data, we get a straight line. For again x value, as we can see, the graph is not resembling any pattern.
For graph quadratic equation, against its observed data, we get quadratic line. And for against x values, as we can see, the graph is not resemble any pattern.
From the cubic equation founded before, the graph against its observed data shows that increasing the advertising budget X initially boosts sales Y significantly, then leads to diminishing returns, but eventually result in accelerated sales growth at higher spending levels. For the cubic equation against X value, it shows the relationship between error vector E and total advertising budget X values. The data in the graph do not resemble any patterns, so we can conclude that there is no relationship between X and E in this graph.
In conclusion, this study investigates the relationship between total advertising budget and sale using linear, quadratic and cubic model. As a result, the linear model proved to be the most accurate since it showed the lowest error magnitude, which is 2.43. This finding was further supported by graphical analysis, which visually confirmed the linear curve as the best fit for the data point.